Okay, let's see how you did on this one. So, the average length of a man's arm. So this is another one that's very debatable. So a man's probably going to be pretty much the same size, for however long until they get older. They might start shrinking. But are they talking about a single man's arm? Or are they talking about every man in the whole world? So that's how you have to look at the problem to decide. And like I said, this is one that could be both. You could say A equals the average length of a man's arm. His arm's going to be the same length for the majority of his life because it's a man, it's not a child. So there we can consider hopefully that they're full grown, which a man is at 18 and lots of times they do keep growing. So to me, this one's a better as a variable changing because like I said, a man's arm gets shorter as he gets older. When he's 18, it's going to get bigger probably before he's 25. But I could see somebody fight for this to be a placeholder. My arm's going to be 36 inches for the next 50 years. So that could be true. So I could see that somebody pick a placeholder. But if we were talking about every man in the world, I would say that's going to be different. So it's how you interpret it. So we'll use placeholder just because there's not very many that can be placeholders. But if you use changing, that's okay. All you have to do is be able to defend it. This man's arm is not the same length as this man's arm. That's not the same length as this man. But we'll say for most of his life, a man's going to have, if he starts out with a 36-inch length, it's going to stay that. And so we could pick, should we do A again? A equals average length of a man's arm. And that would probably be measured in, not feet, probably in inches. But if you wrote something else, centimeters, that would work. You could do feet because you'd have partial feet, but inches is probably the best one. Okay, so everybody do okay on that? So we have our letter, we have what it represents, and we have our variable. And don't erase yours. If yours doesn't match mine exactly, that's fine. As long as you have the parts and you can defend while you wrote placeholder or changing. This is another one that some students argue about in class. Again, I would say it's a placeholder. But they say, well, weather's going to deteriorate it, and I bet it's getting shorter each year because of weather. Yeah, that might be so, but I think they mean for this one to be a placeholder. It's going to be approximately the same height forever. And H is always what we use for height, almost always. So the height of the Washington Monument. And don't ever be afraid to get too descriptive on your variable statements. The more descriptive, the better. And this one is probably measured in feet, so I'm going to put feet. But if you have yards or inches, that's fine. Nobody's counting these right or wrong. We're just writing variable statements. Duration of a monsoon storm in Maricopa County. Now that I would definitely say is changing because sometimes they can come and go in 30 seconds, a minute, an hour. Sometimes they go on a good portion of the evening. So I would definitely say that one is varies. So it's changing or varies, whichever word you want to use for that. So should we use D? For duration of a monsoon, wrong, storm in Maricopa County. And that's probably best in minutes since some are hours, some are minutes. Be easier to compare them that way. Let's see, average snowfall on Mount McKinley. So again, I would say that is changing every year. The amount of snow it gets in the winter season is going to change. I had one student last semester say, well, I would say this is a placeholder because it's the average for that 1 year. And I'm like, well, they really haven't mentioned the year, and that's why I would pick changing. If it said average snowfall on Mount McKinley in 2012, yeah, I would pick placeholder for that. But because this says it's like always going to be changing, 1 year it'll be this, the next year it'll be that, even daily, the amount per day would change daily. So I would definitely call this one changing or varies. I'm going to write varies on this. It's a little bit shorter to write. So average snowfall. So A equals average snowfall. Geez, I can tell it's been a while since I've written snowfall on Mount McKinley. And that I would say, maybe feet, if it's going to be the average for the year. If it's the average for the day, and they're not very specific here, if it was a daily average, I might use inches, but we don't know, so I'm going to write feet. But if you wrote inches, that's fine. Don't change it. It's how we interpret it. And that's why usually word problems are a lot more specific than these are, because if it was daily, you'd probably pick inches. Yearly, you'd pick feet. The amount of money earned on a person's paycheck throughout their lifetime. So I think we can probably all agree this one varies. Hopefully the money you're making at age 18 isn't the same money you're making at age 60. So, I mean, I suppose there's some cases, but I don't think too many. So we'll call this one varies. And, guess we'll use A again. That sure is a popular one. So amount of money earned on a person's paycheck. And I'm not just going to say throughout their lifetime, and then that would be in dollars as well. And last, total cost of your cell phone bill for a 6-month period. Now this one definitely is debatable. Some people have the same cell phone bill every day for 6 months. I'm one of those people, because now that they have the, unlimited everything, a lot of people's are the same unless you buy something or you purchase an app or whatever. What do they call those, greetings or songs or whatever you do to change the bill. So I could go with either one on this one, varies or placeholder, because there are a lot of people, I can know what mine is to the penny every month, that it would not change. But then there's some that pay by the minute, and things like that, so theirs would change. So you pick whatever's best for your cell phone bill. So for my cell phone bill, it would be a placeholder, because mine is the same value, certainly for 6-month periods. It may change every once in a while, but I can have the same bill for 6-month period. So we'll say C equals the cost of my cell phone bill. And that's in dollars. There we go. So that gives you just a little practice, because we are going to have a lot of word problems. Every test has word problems on it in this class, as they will in your next class. So you're just always, there's not too many classes that have all the word problems together. Like in Math 126, we have a test that's real heavy on word problems, like half my test is word problems, but then I have 1 or 2 sprinkled out in every other chapter too. So this is something you'll use forever. Every math class you take, You have to know how to write an appropriate variable statement, including the letter, the description, and then its units. Okay, so these next 2 pages we're going to do are probably 2 of the most important pages in this class. You will be translating expressions forever and ever and ever. You will always be translating expressions, no matter what math class you take. Translating expressions means you're putting words into an algebra expression. So as we go, I'm going to write some tips and pointers down here as we get to them, because I know the areas, I've taught this class so many times, I know the areas where students struggle. And every one of your 3 tests this semester, you have quite a few quizzes. I think you have 2, 3, 4 quizzes, and you have 3 tests plus your final. Every test you take, and probably every quiz too, is going to have some translating on it. So that's why I said this is such an important thing. So use it in all your other classes, plus all of our tests and quizzes have it. So we have 4 less than. So this is a danger zone for students. When they see that, and that's the trick to translating, you just do a couple letters at a time. So if you are 4 years less than me, you're my age minus 4. But guess what students write when they see this? They go 4 minus. Well, you all know that, whoops, subtraction is not commutative, correct? You can't change the order and get the same answer. This one gives me +1, this one gives me -1. So order matters in subtraction. So I think everybody knows it's subtraction. They just don't know where to put the 4. So that's why I made up that problem. If you're 4 years less than me, you're my age minus 4. You're not 4 minus my age. That would make you negative. So you're my age minus 4. So I know that this -4 has to go at the back. And so I want to show you the difference. So there's 2 different phrases you'll run across. 4 less x, 4 less than x. And so I just like you to write little notes down here, so when you're studying for your quizzes and tests, you have that right there. So you can't use notes on your quizzes and tests, but certainly study your notes before you take a test. So 4 less x is 4 minus x, because that's like saying 4 subtracted by x. 4 less than x, though, means x minus 4, because 4 is being taken away from x. It was like the age problem I just said. You are 4 years less than me. Me minus 4. So that little teeny word than makes all the difference in the world. So be on the lookout. And this one is by far the more common one. You'll see them both, but this one is the common one. So you have to remember, when you see less than, more than, you switch the order. That number is being taken away from this one. So be careful with that. And then quotient. So I should have stayed down there at the bottom of the paper. So that's the next thing I want to write, because I noticed that a lot of students don't know the 4 buzzwords for operations. So addition is sum. So anytime you see the word sum, that means addition. Subtraction, the key word for it, and it's not the only word, the key word for subtraction is difference. The difference between x and 4 would be x minus 4. And again, you'll need to know this stuff for every math class you take. It's not just for this class, every class you do. Multiplication is product. Multiplication, I always have to sound that one out. And the key word for that is product. There's other words. Of means multiply. Times obviously means multiply. By is another one. 4 by 3 means 4 times 3. But product is the main one. And then division, the key word for that is quotient, the one that we just saw. And usually in algebra, unlike the lower level maths, we do not use the division sign. So you learn to write it like this in your pre-algebra and classes before that. In algebra, we write it like this. The quotient of x and 4. So we do not use division signs when we're writing algebra equations. Okay. So those are the key words you're going to need to know here. So when this one says 4 less than, so I know it's 4 being taken away because of the than. Then it says quotient, so I immediately put a fraction bar. And like I said, I only read a couple words at a time. I haven't even read the whole sentence yet, or the whole expression yet, or the whole phrase yet. I just read it a little at a time and I write down as I go. And that's the key to being good at translating. So 4 less than means minus 4. The quotient means division. And here's something that's going to help you so much. Find the word and. Anytime you see one of these 4 words, sum, difference, products, or quotient, the minute you see that word, one of those 4, look for the word and. That tells you everything before the and goes first and everything after the and goes second. Such an easy way to do translations if you just know a couple key tricks like that. So you have to know your vocabulary too, but that and is awesome. So twice a number. Twice means 2 times a number. So you could either write 2x or x. And in ALEKS, when you're doing your homework and taking your quizzes and tests, ALEKS is the homework platform we use, they'll tell you what letter to use, so you don't get a pick. They'll say twice a number C, twice a letter C, or twice a number A. So you have to use the letter they say. So I'll switch it up a lot so that you'll see that we just don't use X's and Y's. We have to use what ALEKS tells us. And same way if you weren't doing ALEKS on a teacher's test. Then I see the word and, 7 goes down there. And that trick works every time. So find the word and after you see quotient, product, sum, or difference. Whatever is before the and goes first. Whatever's after the and goes after the symbol. And it doesn't matter whether it's addition symbol or multiplication symbol or subtraction. That works every time. Before the and goes before the symbol, after the and goes after the symbol. And that's my answer. So that's called translating words into an algebraic expression. Okay, so the quotient. So the minute I see that, I go quotient. Get ready for the quotient. And then, because I know there's going to be the word and, I read through my problem and find and. So again, I know 7's in the denominator because it's the only thing after the and. And so what they did is they just rearranged these words to make a totally different problem. Okay, so this is before and, so it's going to go up here. 4 less than, so again I go up here and I write minus 4. So instead of it being back here, it's part of the quotient now, so it's going to be in the top. Twice a number. And these are not the same at all. This is the whole number 4. This is 2x minus 4 over the fraction bar 7. So see, same exact words. They just changed the order a little bit and it made a totally different problem. Okay, I'm going to let you guys try the next one. So go ahead and try the next one and then come back to me when you're done. So shut the recording off and then come back and we'll check our answer. Okay, quotient again. So I know immediately to make a quotient bar. Then I see the word and, because remember, whenever you see quotient, product, difference, or sum, you look for the word and. That tells you what goes before the symbol, what goes after. So this one only has 4 up here. And this says 7 less than. See what I mean by that less than? It's everywhere, right? So minus 7, twice a number. So how'd you guys do on that one? Isn't it cool when you know all these tricks? It makes it so easy. So quotient means division. I look for the word and. Whatever's in front of and goes in the top. Whatever's behind and goes in the denominator, remembering 7 less than means minus 7. Okay, so let's do a couple more and then I'll let you guys practice on a couple. This one is probably one of the most missed. So 3 times the difference. So when I see those 4 words, this is what I immediately do. And that is not what students do on tests and quizzes, unless they study. So, because it says 3 times the difference. The difference is a quantity. So in order to show that 3 times the quantity, I have to put parentheses in, because the difference is a number minus a number. So it's 3 times that whole difference, meaning parentheses. Difference means subtract. Okay, now here's the keyword difference. So I look for and again, and it'll always be there. So you don't have to go, oh, what if it's not there? It's always there. So what goes before it? A number. So let's use in this time. And 5. Cool, huh? But that is one I would highlight or put stars by. A lot of students miss that because they forget the parentheses, but it's not 3 times a single number. It's 3 times a quantity, because difference is something minus something. So parentheses are required. Okay, let's do one more and then we can shut it off and let you guys practice maybe the last 4. How about that? 1, 2, 3, 4. So we'll do 2 more and we'll let you practice the last 4. So the difference, so the minute I see difference, I do that and then I look for the word and. So difference is one of the 4 operating words below. So I know it means subtraction. And then I look for and. Whatever's after and goes second. Whatever before and goes in front of the in front of the subtraction. 3 times a number. So 3n minus 5. So see the difference between this? This was 3 times the difference, where this is the difference first, and it's just 3 times a number, not 3 times a quantity. So these look a lot alike, but they're not even close to the same. Put 8 in there. 8 minus 5 is 3. 3 times 3 is 9. Put 8 in there. 24 minus 5 is 19. Not even close. So they're not the same thing. So this is 3 times the difference. This is 3 times a number. Okay, one more and then you guys can shut it off and practice the last 4 on your own. Because that's the only way to get good at it, is by practicing. If you sit and write down everything I say, you won't remember nearly as much as you will from doing problems and missing them. Missing them is awesome. That's how we learn. We learn from our mistakes. So getting everything right, well, that's great. That means you probably already know it. But missing, just as great, because that's how you learn. And I always tell students when I call on them in class, you missed it? No big deal. We all miss stuff. I miss stuff all the time. But you won't make that same mistake on the test now. Okay, so the difference, here we go again. And because it's one of the keywords, we look for and. 5 is in front of and. 3 times a number is after and. And we saw in subtraction, these are not the same. 4 minus 3 is not the same thing as 3 minus 4. Likewise, these two are not the same. Okay, so turn off your recording, your video, and do those next 4, and don't be afraid of missing them. Just write them in pencil. And what I always recommend with students is if you do miss them, cross it out instead of erasing. You can see what you did wrong and learn for that, and then write it the correct way. Okay, so go ahead and do those 4, and then turn the recording back on, and we will go over those last 4 together. Okay, product. When I see product, I could do 2 things. I could do this. Do you guys all know that means multiplication? Or I could do this, but if either one of these have 2 or more terms in them, I have to do parentheses. So I like to start with the parentheses, and then if I don't need them, I can take them off. It's better than doing this and forgetting the parentheses, because having parentheses that aren't needed, you'll still get it right. But not having parentheses, because this dot means only this number and this number are multiplied. So if you had 2n minus 5 here, only 5 is getting multiplied by what's next. So that's why I always start product with parentheses. And then if I have to get rid of one or both, great, I will on the next step. So there's product. That's another one of our key operation words. So now I have to look for the word and. Oh, here's and. So that means these words go in the first parenthesis. These words go in the second parenthesis. So 4 fewer than. Yes, that's the same thing as 4 less than, if that's what you're thinking. 4 fewer than, 4 less than, same thing. So that means it's n minus 4, not 4 minus n. So it follows this pattern right here. 4 less than, 4 fewer than. So the 4 goes at the end. So 4 less than a number means, what letter should we use now? T. So T minus 4. So that's what goes before and, which means in the first parentheses. T minus 4. 8 more than, same thing with more than. Put the 8 second, so that would be T plus 8. In addition, order doesn't matter, but it's nice to stay consistent, and you're going to learn later on in this class that we always put our variables first. So, I mean, this would be an exception, obviously, because we can't switch the order there. But when we have a choice, like in addition, because T plus 8, 8 plus T, the same thing, we usually put our variable first. So because it's more than, just like fewer than, that means a number added by 8. But if you wrote 8 plus T there, that's okay. Now this one, I can't drop either parenthesis. And if you wrote it without parentheses, it is wrong, because only the 4 and T would be multiplied if you had a times sign there. So 2 or more items always stay in parentheses when we're multiplying. Okay, next we have 4 fewer than. So we know that's minus 4, right? It's the same thing as 4 less than. And you could do this too up here, right? Fewer. Just so you remember, it's 4 fewer than or 4 less than. So 4 fewer than says immediately put the 4 at the end. Product says do your 2 parentheses, and if you have to drop one or both of them later, fine, but you got them there if you need them. So products taken care of. Now we have to look for the word and. Always look for and when you have product, sum, difference, or quotient. Before and is just a number. So you can see on this one, we're not going to need those parentheses. If you keep them, it's not wrong. It's only when we have 2 or more terms that they're required. And then 8 more than a number, t plus 8. So the easiest, best way to write this one without the extra parentheses is this, but they would both be counted right by teachers, by computers. They're both correct. But general guidelines, 2 or more terms stay in parentheses. A single term does not need it. But this is absolutely correct too. It's just a little busy. So I like to simplify it as much as I can. Okay, so let's move to this next one. 7 more than. So again, there's that than word, so I put my 7 at the end. Remember, addition order doesn't matter, but it's nice to be consistent. And then you don't have to go, is this the one I write at the end or is this the one I write at the beginning? When you see that than, boom, shove it right to the end. Product again. And because it's an operation word, look for the word and. So the number is after and, so that's all that's going to go at the end. And before and is reciprocal of a number. Oh, interesting. New vocabulary there. So reciprocal. Let's go down here. That's a good one just to remind ourselves what it is. Okay, Kim. Stop talking and write. So reciprocal. That's a O and that's a C, by the way. So 3 and 1/3 are reciprocals. 2/3 and 3/2 are reciprocals. Basically, in layman's language, you're flipping it because 3 is really 3 over 1. So when you flip it, it's 1/3. 2/3, when you flip it, 3/2. So if our number is t, the reciprocal is 1 over t. So on this one, you probably don't even really need parentheses at all. You could write it as 1 over t times t plus 7. I would say on that one, either one's good because that's a little bit busy. It's nice to keep it in parentheses, but like I said, having too many parentheses is never wrong. Not having them when you need them, that's when it will get counted wrong. So if you're ever in doubt, it's better to make sure and write them. The product of the reciprocal of a number and 7 more than the number. So here's our last one on this page, and we got more on the next page. Lucky you guys, right? Okay, so product again. Get your 2 parentheses ready, and you can write a second step if you want to drop them. Of the reciprocal of a number and 7 more than the number. So before, so we got the product. Reciprocal of a number is in the first parentheses because it's and before the and. Reciprocal of a number, 1 over t. And this is what goes in the second parentheses, t plus 7. And again, I would probably leave both of those in. Legally, you can drop the first one if you want, because it only has a single term, where this one has 2, so you'd have to keep that one in parentheses. But either or, like I said, adding parentheses, never wrong. Okay, so I think I'm going to stop the video there and I'll start the next one on the next page. So I'll see you in a bit.